Hi guys, hope you are doing great. So today we will be starting the home automation tutorial series for the absolute beginners. This will be the part 1 of the 4-part series which I'll be uploading in this channel for every week. So if you haven't watched my home automation video which I uploaded in my channel, I strongly suggest you to go and watch that so that you will get a grasp of what we'll be doing or learning in this entire series. So without any further ado, let's get started. Alright, so since we are starting up this project, it's better that you know all the technologies we have included in this project. So this will get you a brief idea on how all these devices communicate with each other and will make your life easier so that you can set up this in your home or office or anywhere else. So the architecture of our project is somewhat like a client-server architecture. Those who don't know what a client-server architecture is, let me quickly explain that. It's nothing but a collection of clients which are connected to a centralized server and they will receive and request the services from that centralized server. So in our case, the Raspberry Pi will act as a centralized server and all the ESP devices and the phones will act as the clients. Throughout this video, I'll be using the Raspberry Pi, and you can also use your phone instead of the Raspberry Pi to save the cost. I'll be explaining with the Raspberry Pi. If you want a video on how to use phone instead of Raspberry Pi, let me know in the comments. Much like how we communicate with each other using different languages, these devices communicate with each other using a set of instructions called the MQTT protocol. And MQTT protocol is a framework for the IoT communications which is most popular currently. So in this we will be using MQTT protocol to communicate with our devices. For example, let's say client 1 is an ESP device connected with the light and client 2 is our mobile phone. So when we click on a button on our Google Home app saying that I need to switch on the light, and that instruction will be sent to the Raspberry Pi and the Raspberry Pi will in turn reroute that message to the exact ESP device, and the code running on the ESP device will instruct or control what to do with that message, and depending on the message status our device or the light will be turned on or off. That is a simple explanation which I can give. To this, we'll add the Google Home functionality using Google Actions webhook. If you heard of Amazon Alexa or the Google Home or Google Mini, it's basically a virtual assistant built by Google. So as a third-party developers, we can create custom Google Home actions, and based on that we can turn our devices on or off. Alright, so this is what our project architecture will look like. All of the communications are happening inside our local network, which has some major advantages. So if you have used any Philips Hue lights, you will know operating it via their app will take significant amount of time, which is not in the case with our system because everything happens quicker than you would expect. However, there is a risk involved in opening the port to the external network. But it's not a big deal since we are encrypting all our communications using the SSL certificate. So I think you got a solid understanding on how all our setup works. Now let's check out the components which we require for building this. We don't have that much of components involved around this project. We need an ESP8266, Raspberry Pi, relay module, AC to DC power supply module, FTDI board, some mail headers and some jumper wires. Alright, so let me quickly explain what all these things do. First is our ESP8266 chip, which is the main part of our project. The specific version which I am using is the ESP12F. It is a microcontroller in which we can flash our software and communicate with them over the Wi-Fi network. There are many versions out there, but I would recommend you use the specific version which is the ESP12F. As it is a tiny device, you will require soldering the wires to the pins. There are some development boards available with this chip called the Node MCU boards, which will have soldered pins so that it will make your life easier. Next is our Raspberry Pi, in which we will install the MQTT broker and the smart home Google Action. We will run this inside the Raspberry Pi using the Docker containers, which is another topic to discuss. Next is the relay module. Think of it as an electrically operated switch. We can connect our appliances to the relay and we can control the appliances by providing a low DC voltage. And the final part is the AC to DC converter. The devices which we connect inside the switch box will work only in DC voltage. So we need an output of 3.3 and 5 volt. Like the ESP works in 3.3 volt and the relay works in 5 volt. Luckily, we have some modules available in the market which provide both the voltages from single module. Links will be in the description so that you can have a look. Alright, so here ends the first part of the video, and in the upcoming part I'll be explaining you how to set up the MQTT broker and also the Google Actions webhook. We'll be running these in separate Docker containers and we'll be also flashing the code into the ESP. So thanks for watching and stay tuned.